Hello, my name is Nicholas, and I'm a member of the Wolfram Alpha Math content team. Welcome to the Wolfram Tech Conference. Among the other dozen talks I'm sure you're attending today, we'll be talking about new Wolfram language functionality that's been incorporated in Wolfram Alpha in recent times. So I'm not going to spend too much time on the abstract. I'll pause here for a moment in case in the future, in the version hosted on the web, you can pause and read the abstract if you'd like. I do want to highlight thanks to the Wolfram Alpha Math team, of which I'm a member, and the rest of the Wolfram Alpha developers, of course. So Wolfram Alpha is perpetually in a process of trying to keep pace with the Wolfram language itself. So Wolfram Alpha is a large-scale development project written in the Wolfram language. It supports a broad ensemble of functionality across many disciplines, from many facets of math, elementary mathematics, algebra, geometry, calculus, linear algebra, differential equations, ODEs and PDEs, statistics, etc. All of the various versions of applied math, for example, science and technology, physics, chemistry, engineering, materials, computational science, and then other aspects of life that most normal humans care about, society and cultural facts, everyday life, data pertaining to those things, etc. All of this is rooted in the Wolfram language and the broader Wolfram technology stack. And Wolfram Alpha is, at least of what I know, one of the largest development projects done in the Wolfram language. And as those Wolfram language roots grow version by version, so too does the Wolfram Alpha web page and API accessibility. So Wolfram Alpha is a natural language pipeline to the Wolfram language itself. So a way to, with common tongue, communicate with the computer and extract data and calculations that you're interested in without ever having to code, right? So this serves, the front-facing immediate thing everyone thinks of is the website, right? So for external users, they log into the website, type in a query in natural language, they get data or computations out of it. It also has accessibility to other softwares via web-based APIs and partnerships with major corporations such as Apple, where we incorporate things for Siri, such that you get spoken results, Amazon, where you get spoken results with Alexa, and Microsoft, in which Wolfram Alpha functionality, calculations, data, accessibility, etc., is being incorporated in Excel, for which I have various logos at the bottom here. So basic function additions rendering accessible Wolfram language functionality in Wolfram Alpha is critical to both the development of the web page everyone associates with Wolfram Alpha most readily, and critical to the development of content for web API accessibility and partnerships in which software accesses the Wolfram language via Wolfram Alpha. So we'll cover a broad range of functionality additions we've made to Wolfram Alpha based on progress in the Wolfram language. And this includes content that we've been adding in particular from version 9 onwards, as we're trying to keep pace with Wolfram language developments. So a simple query, some content that you can imagine, you can conceive of a way of programming in, say, Excel, or God forbid, C++ or C, a low-level language, fairly easily. Say you want to call a function that will generate a vector of a certain length, and have that vector be at a certain angle with respect to the x-axis, right? That's a couple trigonometric functions in a few cells in Excel, or a couple trigonometric functions in some custom library that you're calling from C++. It's about 15 characters if you just use APIs or software with accessibility to Wolfram Alpha. And so you can see here, if you can see my mouse, you can see we type in a natural language query, angled vector of length 30 at an angle of pi over 4 with respect to the x-axis. It shows you its understanding of what you stated and the corresponding result. This is fairly straightforward to any Physics 1, Physics 2 student, and you can implement this in a broad array of softwares, but you can do this probably most easily by just natural language input in Wolfram Alpha. Similarly simple example on extracting the absolute value and complex arguments in tandem from, say, a list of quantities that you're interested in. For example, here, 1 plus I, 3 plus I, 5 plus I. You could conceive of writing functionality, even for the complex argument in some other software. It likely wouldn't just be 10 to 20 characters, right? And in this same instance, you can see, I'll scroll down a little bit. You can see it understands your input. It takes the input, calculates the absolute value in the argument of each of those entities in the list of queries that you wanted to make, and computes the immediate result absolute value argument for each of the quantities. Additionally, and this would take additional code in another software, you can ask for alternative forms, so other equivalent symbolic representations of these result quantities, and convert them to, say, logarithmic expressions or other trigonometric expressions. So continuing this vein of just basic function additions that make what would be a fairly straightforward job in another software still significantly faster. We have something where, say you want to do a combination of string reversal of an integer, and you want to convert that new number to a different base, and then only return a certain fraction of those the leading digits. So that's again about 10 to 20 characters in the Wolfram language, where we've added functionality for the function integer reverse from the Wolfram language to Wolfram alpha. You can type in, switch around the integer 1, 2, 3, 4, 5, so 12,345. Do that and return the new result in base 5 rather than base 10, and retain the leading 10 digits. And if you compute this, it shows you what it interpreted as your natural language input, and returns the result of 1,858,125, and then gives you a couple other representations, including things like the number length, number name, etc. Getting a little bit more difficult in terms of implementation in another software would be the inquiry of if a given number corresponds to a Mersenne prime exponent. Right? So we want to know, does 10 to the 10 correspond to a Mersenne prime exponent? Now, I'm not familiar enough with the mathematics behind how you would write a query like this, and so I can't conceive of exactly how you would do this in Excel or something, but it wouldn't surprise me if that's feasible. However, it's certainly feasible in Wolfram Alpha, right? In 10 to 20 characters, you get the answer that no, 10 to the 10 does not correspond to a Mersenne prime exponent. So all of that stuff in principle, you could conceive of writing in another software fairly simply. As you get more involved in higher level mathematics, for example here, rotational matrices, it becomes more and more laborious to do those kind of things in another language, but comparable difficulty to return the computation in Wolfram Alpha. So you'll remember 10 to 20 characters before got you the absolute value and argument of a string of numbers. Here, the same number of characters, about 10 to 15, will get you a rotational matrix called an Euler matrix, corresponding to rotations about the X, Y, and Z axis. So I've just typed in some reference values by which we want to rotate. It produces the rotation matrix by which you would multiply a vector in order to get the rotated new vector. And that already is, okay, that would be a trigonometric headache in some other software. However, it would be a linear algebra headache as well to return the extra pods that are returned here, such as characteristic polynomial, the eigenvalues, eigenvectors, and in particular, the diagonalization of that rotation matrix. So increasing degrees of complexity in terms of the computation do not necessarily entail increasing degrees of complexity in the natural language input that invokes that computation. And this is a major selling point of Wolfram Alpha's website and the ability to interface with other softwares. It saves you development time for major projects. It saves you fun time for, I mean, unless you're into implementing mathematics and code, it saves you fun time as you make natural language queries just on the website. Similarly, for another kind of advanced math topic, elliptic functions. So a German guy named Weierstrass invented a few elliptic functions. And these have corresponding quantities associated with the half periods, 3 half periods associated with these, 2 unique ones and 1 derived one. You can make queries on what is the third half period of a Weierstrass elliptic function corresponding to the first invariance and the first and second invariance rather, with a given numerical value. And this will return, without you having to do any symbolic calculations under the hood, a number, in this case a purely imaginary number, the position in the complex plane, a data visualization of that, and tell you the functions that it used, or some of the functions that it used in the Wolfram language in order to compute these things. So this whole process of incorporating Wolfram language functionality in Wolfram Alpha lends itself to direct function calls. It also lends itself to, in applied mathematics in particular, the calculation of other quantities of interest based on a given function that we think people might be interested in for educational purposes, etc. For example, we've had feature requests in signal processing where certain filters are used to attenuate a signal. This attenuation, for example, in audio technology, would be used to reduce white noise in some low fidelity recording, such that your old time recording of some opera from the mid 1900s sounds better on your modern technology, your modern stereo. And so audio engineers will use these things called window functions. There's about 24 of them so far in the Wolfram language, all of which we're in the process of adding support for in Wolfram Alpha. You can see here, if we type in Han window, one of the most basic window functions, you get a plot back of the mathematical window function itself versus its variable, x. And you get the resulting power spectrum. And this is in units of frequency relative to the harmonic of the input sample, the input audio signal. You get the frequency attenuation that you would expect if you apply this window function as a filter to the audio signal. And so each of these have a different power spectrum or extent to which they attenuate different signals relative to the original sample. And so each one is adept at reducing a certain type of noise. Say one window function might be adept at eliminating pink noise, one may be adept at eliminating white noise, etc. And this enhancement of Wolfram Alpha's capacity to return derivative quantities of interest, such as the power spectrum, from a query such as what is the Han window as a function of x, is one of the redeeming qualities of Wolfram Alpha as an educational utility and as an information utility for, say, engineers in this case. So Wolfram Alpha, we're focusing on, in this talk, mathematics. So the support for pure mathematics in the first portion of the talk, support for a cool instance of applied mathematics in the latter portion of the talk there. This support for mathematical functionality is increasingly comprehensive. The exhaustive scientific content and mathematical content of the Wolfram language is paralleled in Wolfram Alpha, such that if you make a query in the Wolfram language using this mathematical function data symbol, you can return a host of functionality, about, I think, 400 functions, 300 to 400 functions, depending on your version of Wolfram language you're in, that are basic to advanced mathematical functions. This is a good notion of what functionality Wolfram Alpha should support and the Wolfram language should support. Of these, there are about 150 in, I think, version 11 I used to generate this. There are about 150 of these that are supported directly in the Wolfram language. This number is increasing rapidly as versions proceed. I think it's already increased some from when I made this in version 11 to version 12.1. All of these that the Wolfram language has in the mathematical function data repository are supported in Wolfram Alpha now. The 24 signal processing functions and the few other highlights that I've had here in this talk polish the mathematical data function support off from the amazing amount of progress the math content group and the other developers with Wolfram Alpha already had. So in this ever increasing Wolfram language pipeline that is Wolfram Alpha, we've covered additions such as basic mathematics, computation with angles, their relation with vectors, computation with complex numbers, computation with string rearrangement, integer reversal, and base conversions, computation with advanced mathematics, elliptic functions, rotational matrices, and applied mathematics in engineering in signal processing. This is a small example of the progress that the Math Content Group and the other Wolfram Alpha developers have made in recent times for enhancing the support of the Wolfram language in Wolfram Alpha. I'm happy to address other questions that you have on upcoming functionality if you'd like to reach out to me at my email here, and with any questions immediately following the talk. Thank you.
If anybody has any questions, I'm happy to take them. I will mention as you think of questions, if you have any, that I failed to highlight in that histogram that I showed at about 14 minutes, that there have been with respect to the function rank, and which is the frequency of occurrence in the Wolfram language documentation, which you can get from Wolfram Alpha, such that some occur, you know, they're the top 100 or 200 functions in terms of frequency of occurrence. And sorry, I played the video. Some are the top 200 most used functions in Wolfram language. Some of them are, you know, the 4,000th most frequently used function. And we've added support for these across the board. I think that's the only other clarifying thing I mentioned, or I wanted to mention. So if you have any questions, I'm happy to take them.
Nick, we got one question right here from Michael for you.
Oh.
It's in the Pathable chat.
Yeah, sure, yeah. So yeah, I guess everybody can see it on PathOVS for a notebook covering all of this. And yeah, I can attach that. I'll note that we're in the final stages of adding most of these features, and so the function calls right now probably won't return what you see in the notebook itself. But I can attach that here shortly after the session, and you can at least see what I showed in the video itself, and then at some point that functionality will just return with a nicer looking even set of pods from the Wolfram Alpha function in Mathematica or the Wolfram language. So yeah, I will upload that right after the talk. Yeah, sweet. Yeah, my manager highlighted 2 to 4 weeks till most of the stuff goes on the production Wolfram Alpha servers, we believe. So Michael asked if the Wolfram Alpha evaluator is different from the normal Mathematica kernel, and if so, how. So the function that I was using to illustrate what the input strings that will in the future prompt the calculations that you were seeing there is the Wolfram Alpha function. So I'm assuming that's what you're referring to as the Wolfram Alpha evaluator, and that will actually query Wolfram Alpha and then return piece by piece what pods that it computes. And so it can do that in just by returning the pods directly. So you can just request all of the pods. That's just Wolfram Alpha of and your inquiry string. So say Wolfram Alpha of Euler matrix 1, 2, 3, or you can request on a pod by pod basis, or you can request the computable data version of that, where it strips away the pod representation and actually gives you, say, the list that's the output for the matrix. There is a syntactical way to request that when you're making the function call to the Wolfram Alpha function in Mathematica from the kernel. And there's also, if you just make the function call without any of the options, say Wolfram Alpha of Euler matrix of 1, 2, 3, and then when it returns all of the pods, at the top right of each pod, I believe, is a little ... option extension where you can say return the computable data for this pod, or return the just this pod specifically, etc. And it will give you back how you could have asked for that syntactically. And so I think it's easiest to use that Wolfram Alpha function to return all of the pods and then access the piece-by-piece components from the interactive interface. Yeah, the Wolfram Alpha function will run in a normal Mathematica kernel and then return the Wolfram Alpha calculation associated with your input string. I hope that's what you were asking about with the Wolfram Alpha evaluator. Right, so Michael pointed out that there are Wolfram Alpha functions that are not in Mathematica potentially. And I think there is, I'm not familiar with the Rainbow Financial Derivatives content here specifically, but there is content that is in Wolfram Alpha specifically that has been developed from kernel functions but aren't necessarily kernel functions themselves. And that's likely the content that you're talking about here with the Rainbow Financial Derivatives. There's other financial things like amortization calculators and stuff like that that when they were developed, there weren't kernel functions associated with that content, such that we did the effective interest calculations, etc., by hand or using what kernel functions did exist. And I think in that sense, not only is Wolfram Alpha trying to keep up with Wolfram Language developments, but the Wolfram Language also reflects developments that have already been done in Wolfram Alpha to some extent, wherein we'll write an amortization calculator not using kernel functions because they don't exist yet, and then kernel functions will crop up within the next 5 years after that. And so yeah, there is some development that is done on the Wolfram Alpha side, and input strings will parse to those functions that are not necessarily supported in the Wolfram language with at least the level of simplicity that I've highlighted here. Yeah, so Kyle, just reiterated that there's many custom functions in Wolfram Alpha that are not inherent in the Wolfram language from a direct symbol, but are built into Alpha specifically for its development, and that there's a lot of use of JavaLink or JLink as well. We'll also note that I've only been working for Wolfram Alpha for about 6 months, so I'm sure that Kyle and other members of our team could answer this a lot better.
Jeremy, did you still have a question?
Yeah, that's a good point. That we should, the two softwares should try to keep pace with each other. There's at the bottom of like the Wolfram Alpha page, there's a feedback form, and I mean that's designed for Wolfram Alpha feedback specifically. But I'm sure if you put something in there that, like a feature request, say Wolfram Alpha supports this, it'd be great if Wolfram Language could support this as well. That will make it into our bug system, and I'm sure it will be filed as a feature request. And so if there are specific financial functions that you're seeking, I'm sure you could, on that form or another feedback form on the Wolfram website, request features. Okay.
All right, we got one more question from Michael. I'm going to go ahead and unmute him and let him talk.
Sure.
Yeah, I was just saying it's just not me. It's also, I've constantly met people who are saying, oh, I can get this amazing stuff from Wolfram Alpha, but I have no way of doing it actually in Mathematica, but it obviously must be written in Mathematica at some level, and it's on that server. Could that function be made available? I don't see anything wrong with that. Actually, I think that would help a lot because, for instance, we used to have a wonderful little thing, which they've now stopped, where you could actually ask for a portfolio analysis just by listing tickers, and it would give up to 4 or 5 tickers, and then it would do a complete portfolio analysis for you. But there was nothing corresponding. I could see parts, and I could generate copies of this by doing some of my own coding, but still, it would be interesting to have such a function, as must exist already in Wolfram Alpha. And rather than reinventing the wheel all over again, it would be good to have those available in Mathematica. The way I got around it, of course, was to call Wolfram Alpha inside a Mathematica function. But that, depending, so that worked fine until I'd give a presentation. And of course, you'd have the 2 streams coming in, a call to Wolfram Alpha, plus your Zoom screen and whatever. And as you know, they don't work wonderfully. And so the whole thing would freeze. So it would be good if these functions could be, transferred over. I mean, they're there. I can't see what great difficulty there must be, unless they're so enmeshed in other functions that go down so many levels that it's just too much of a nightmare to ever undo the lot. But it would be something, I think, which would not only increase the functionality in Mathematica, but allow for a greater correspondence between the 2 functions, which has been an ongoing thing over the, really for the past decade. So.
Yeah, that's a good point that, and Kyle and Jeremy have made mention in the chat here that in instances where things are not too nested, such that there is a dedicated function that we can extract, we've made effort to take those Wolfram Alpha internal functions and turn them into Wolfram function repository editions. So stuff that is not necessarily a kernel function because of the long development times of that, but stuff that is accessible from the kernel by calling a resource function.
Yeah.
And so we have been putting an effort to convert what is the functions that are not too nested in many layers, like you were saying, to function repository additions. In terms of stuff that relies on data, like financial information, for example, portfolios and stuff, I think at some point, sometimes if you run polyhedron data or chemical data, you'll have a small wait time because it's downloading something from the server. So I'm not sure if we can get around that that kind of functionality. But yeah, I'm very in support of the community development aspects of making things a little bit more open and stuff on and the function repository serves that purpose well, and we're trying to move in that direction.
Yeah, I have looked at that, but often you find that there's some function and it's wrapped in compute, which does nothing in Mathematica, but is obviously calling an evaluator in Wolfram Alpha. So I'd have to download all of the Wolfram Alpha application in order for it to work.
Yeah. In instances, if you find a function that you think seems like conceptually it would be easy to separate from the other developmental code, like feel free to send us a bug report and stuff like that, and we'll try to make those functions.
Okay, all right, that would be great. Thank you very much. Thanks,
yeah,
Nick.
Thank you. No problem. Thank you. I think we still have 9 minutes because my talk ran a little bit short. So if anybody else has questions, feel free. I think it will automatically boot us at 4:40, but so we've got 9 minutes. Yeah, Jeremy highlighted specifically. There's with a link that he provided in the chat there, content where you can pin down what stuff has been added by internal users, such as our group, the Wolfram Alpha Math content team. You can look at the function repository additions that our group has done specifically, such that you don't have to dig through all of the Wolfram function repository additions to find the stuff that we thought was best transferred from the Wolfram Alpha internal code to kernel accessible functions. So that subset of the WFR might be interesting to you. Stuff will these functions, as they're listed in the notebook, will compute in the next 2 to 4 weeks likely. And so if you run them right now, it may return no information in that these are very current developments. But yeah, we can upload the notebook, and if nobody else has any questions, we'll wrap up and go ahead and do that. Well, thank you, everybody.